In the previous video, we were doing exercise 5.3 and question number first. The last question was remaining. The last question, the last part, it was remaining. So find the remainder when the given polynomial is divisible by 5 plus 2x. So the process was, we make 5 plus 2x equals to 0. 5 plus 2x equals to 0. Then we find the value of x. 2x equals to minus 5 and x equals to minus 5 by 2. And the polynomial is given. Px equals to x cube plus 3x square plus 3x plus 1. Now we put the value of x equals to minus 5 by 2. So p minus 5 by 2 is minus 5 by 2 the whole cube plus 3 into minus 5 by 2 the whole square plus 3 into minus 5 by 2 and plus 1. So we get minus 125 upon 8 plus 3 into 25 upon 4 minus 15 by 2 and plus 1. Then 125 upon 8 plus 75 upon 4 minus 15 by 2 plus 1. By taking LCM, we get 8. So minus 125 plus 150 minus 60 plus 8 and 150 plus 8 158 and minus 125 minus 60 minus 185 upon 8 and this comes to be minus 27 by 8. So this is the remainder. Now by the division method we will do this question. So 5 plus 2x. 5 plus 2x. We divide the given polynomial by 5 plus 2x. Hello. So we can write 5 plus 2x can be also written as 2x plus 5. And we are told that this is the divisor and the dividend is x cube plus 3x square plus 3x plus 5. Now the first term of dividend is x cube and the first term of divisor is 2x. So x cube divided by 2x. We get x square by 2. So here we write x square by 2 and x square by 2 multiplied by both the terms and would be written below the term. So x square by 2 into 2x. 2x multiplied by x square by 2. 2 and 2 gets cancelled and it comes x cube. Then 5 multiplied by x square by 2. So 5 by 2 x square. Now change the sign. X cube gets cancelled from both the terms. X square is common. So it would be written 3 minus 5 by 2 x square and plus 3x. Taking LCM, 3 into 2, 6 minus 5, 1 by 2. So x square by 2 plus 3x. Now we divide. Now the dividend is x square by 2 plus 3x and the first term is x square by 2 and the first term of divisor is 2x. So divide x square by 2 by 2x. So x square by 2 upon 2x. Then it comes x square by 2 into 1 by 2x and we get x by 4. So here we write x by 4 and 2x multiplied by x by 4. 2x multiplied by x by 4. It comes x square by 2. And 5 multiplied by x by 4. It comes 5 by 4 into x. Sign gets changed, cancelled, x is common. So 3 minus 5 by 4 x. And the remaining there was 1. 3 minus 5 by 4. 3 minus 5 by 4x plus 1. Taking LCM, 12 minus 5, 7 by 4x plus 1. Now 7 by 4x is divided by 2x. So 7 by 4 into x divided by 2x. We get 7x by 4 into 1 by 2x, x and x cancelled, and it comes 7 by 8. So here we write 7 by 8. So 2x multiplied by 7 by 8. It comes 7 by 4x. And 5 multiplied by 7 by 8. It gives 35 by 8. Sign changed. And 1 minus 35 by 8. We get 8 minus 35 minus 27 by 8. So the remainder is minus 27 by 8. So by both the method, by division method we can find the remainder in this way, and by using remainder theorem method we use this question. The next question is, find the remainder when x cube minus ax square. Find the remainder. When x cube minus ax square, x cube minus ax square plus 6x minus a plus 6x minus a is divisible by x minus a. We have to find the remainder when the given polynomial is divisible by x minus a. So we use the remainder theorem. And what is remainder theorem? In the very first step, we have to make x minus a equals to 0 and find the value of x. So make x minus a equals to 0 and find the value of x. We get x equals to a. Then put the value of x equals to a in the given polynomial. And the polynomial is px equals to x cube minus ax square plus 6x minus a. Put the value of x equals to a and solve, we get the remainder. So a cube minus a into a square plus 6 into a minus a. Then we get a cube minus a cube and plus 6a minus a. A cube and a cube cancel, 6a minus a 5a. So the remainder we get 5a. And the third question, check whether, question number 3, check whether 7 plus 3x is a factor of 7 plus 3x is a factor of 3x cube plus 7x, 3x cube plus 7x, 3x cube plus 7x. So we have to check whether 7 plus 3x is a factor of 3x cube plus 7x. So we make it equals to 0. 7 plus 3x equals to 0, and you find the value of x. Then you put the value of it in the given polynomial. If the expression, if the result comes to be 0, then this is the factor, otherwise it is not a factor. So make 7 plus 3x equals to 0. Find the value of x. 3x equals to minus 7, and the value of x be minus 7 by 2. Now the given polynomial px is 3x cubed plus 7x. We put the value of x. 3 into minus 7 by 3 the power 3 plus 7 into minus 7 by 3. So 3 into minus cube, minus multiplied by 3 times, it gives minus 7 raised to the power 3. So 7 into 7, 49, and 49 into 7, 343. So 343 and 3 raised to the power 3, 27, minus plus minus minus 49 by 3. So 3 9s are 27, and minus 343 upon 9, and minus 49 upon 3. We get the LCM 9. So minus 343 minus 49 multiplied by 3, and this comes to be minus 490 upon 9, which is not equals to 0. So we can conclude that 7 plus 3x, 7 plus 3x is not a factor of 3x cubed plus 7x. Remainder doesn't comes to the 0. It means 7 plus 3x is not a factor of 3x cubed plus 7x. Now we do exercise 2.4. The first question is, determine which of the following polynomials has x plus 1 as a factor. Determine which of the following polynomials, which of the following polynomials has x plus 1 as a factor. We have to determine which of the following polynomials has x plus 1 as a factor. The first part is x cube plus x square plus x plus 1. X cube plus x square plus x plus 1. The second part is x4 plus x cube x raised to the power 4 plus x cube plus x square plus x plus 1. Third part is x4 plus 3x cube x raised to the power 4 plus 3x raised to the power 3 plus 3x square plus x plus 1. And the fourth part is x cube minus x square, x cube minus x square minus 2 plus root 2x, 2 plus root 2x plus root 2. So in each of the following, we have to find which of the following polynomials, which of the given 4 polynomials has x plus 1 as a factor. So firstly, we make x plus 1 equals to 0. X plus 1, make x plus 1 equals to 0. Find the value of x. We get x equals to minus 1. Now we have to put the value of x equals to minus x in each of the following given polynomials, and if the remainder comes to be 0, then we say that x plus 1 is a factor, otherwise it is not a factor. So the first part is a polynomial is given x cube plus x square plus x plus 1. We put the value of x equals to minus 1 in the given polynomial. So minus 1 raised to the power 3 plus minus 1 raised to the power 2 plus minus 1 plus 1. We get minus 1 plus 1 minus 1 plus 1, minus plus gets cancelled, and p of minus 1 equals to 0. So we can say that x plus 1 is a factor. X plus 1 is a factor of x cube plus x square plus x plus 1, because remainder is 0. For second part, the polynomial is x raised to the power 4 plus x cube plus x square plus x plus 1. Again we put the value of x equals to minus 1 in the given expression. So minus 1 raised to the power 4 plus minus 1 raised to the power 3 minus 1 raised to the power 2 minus 1 and plus 1. We get minus 1 raised to the power 4 plus 1, then here we get minus 1, then plus 1, minus 1 plus 1. So plus minus cancel, plus minus cancel. The remainder comes to be 1, not 0. Since the remainder is non-zero, so we can conclude that x plus 1 is not a factor. X plus 1 is not a factor of x raised to the power 4 plus x cube plus x square plus x plus 1. Now the third part, the polynomial is given px equals to x raised to the power 4 plus 3x cube plus 3x square plus x plus 1. Again we put the value of x equals to minus 1 in the given expression. So minus 1 raised to the power 4 plus 3 into minus 1 raised to the power 3, 3 into minus 1 square plus minus 1 and plus 1. We get plus 1. Here minus 1 the power 3 minus 1 minus plus minus 3 minus 1 the square plus 1 3 minus 1 plus 1. So minus 3 plus 3 cancel, 1 minus 1 cancel, the remainder comes to be 1. P of minus 1. P of minus 1 equals to 1. So again we conclude that x plus 1 is not a factor of x raised to the power 4 plus 3x cube plus 3x square plus x plus 1. The fourth part is, in the same way, we put the value of x equals to minus 1 in the given expression, and the polynomial is x cube minus x square minus 2 plus root 2 into x plus root 2. Put the value of x at minus 1. So minus 1 cube minus 1 the whole square minus 2 plus root 2 into minus 1 and plus root 2. Then we solve this expression. So minus 1 the power 3 minus 1 the whole square 1 and minus plus 2 plus root 2 and plus root 2. So minus 1 minus 2 plus 2 cancel and root 2 plus root 2. We get 2 root 2. So P of minus 1 equals to 2 root 2. Again the remainder doesn't comes to be 0. So we can say that x plus 1 is not a factor of x cube minus x square minus 2 plus root 2x and plus root 2. Now question number 2. In this question we have using factored term determine whether gx is a polynomial of px, whether gx is a factor of px. Question number 2. Determine whether gx is a factor of px. Gx is a factor of px. We have given two polynomials px and gx. So the first part is px equals to px equals to 2x cube plus x square minus 2x minus 1 plus x square minus 2x and minus 1. Then the polynomial gx is x plus 1. Gx is x plus 1. And we have to determine whether gx is a factor of px. So we make x plus 1 equals to 0. We make gx equals to 0 means x plus 1 equals to 0 and calculate the value of x. X equals to minus 1. Then put the value of x equals to minus 1 in the given polynomial px. And if the result comes to be 0, then we say that gx is a factor of px, otherwise not. So put the value of x equals to minus 1 in the polynomial px. So 2 into minus 1 the cube plus minus 1 the whole square minus 2 into minus 1 minus 1. So here we get minus 2 plus 1 plus 2 minus 1. So minus 2 plus 2 cancel, plus 1 minus 1 cancel, and p of minus 1 equals to 0. Therefore, gx is a factor of px. Gx is a factor of px. Similarly, the third part is px equals to x cube minus third part is px equals to x cube minus px equals to x cube minus 4x square plus x plus 6 minus 4x square plus x plus 6, and the expression gx equals to x minus 3. So we make x minus 3 equals to 0. X minus 3 equals to 0, and find the value of x. Then put the value of x equals to 3 in the polynomial px. So 3 raised to the power 3 minus 4 into 3 square plus 3 plus 6. This is 27 minus 9 into 4 36 plus 3 plus 6 9. 27 plus 9 36 minus 36 0. So we can say that dx is a factor of px. Gx is a factor of px. So we have to make px equals gx equals to 0. We have to find the value of x. Then put the value of x in a given polynomial px. If the result comes to be 0, then we say that gx is a factor of px. Now question number 3. Find the value of x. Find the value of k. Find the value of k if x minus 1 is a factor of px. Find the value of k if x minus 1 is a factor of px. Find the value of k if x minus 1 is a factor of px in each of the following. And the first part of the question is px equals to x square plus x plus k. Px equals to x square plus x plus k. So firstly we have to make x minus 1 equals to 0 and find the value of x. X equals to 1. Then put the value of x in the given polynomial and make it equals to 0. So 1 square, x square, put the value of x, 1 square plus 1 plus k, and make it also equals to 0. So we get 1 plus 1 plus 1 plus 1 plus k equals to 0, and k plus 2 equals to 0, and the value of k comes to be minus 2. The second part of this question, px equals to to 2x square plus kx plus root 2. 2x square plus kx plus root 2. Again, we make x minus 1 equals to 0. Find the value of x. Put the value of x in the given expression. And also make it equals to 0. Also make it equals to 0. Calculate the value of k. This comes 2 plus k plus root 2 equals to 0, and the value of k comes to be minus 2 plus root 2. The third part is px equals to kx square. Px equals to kx square minus root 2x. Kx square minus root 2x plus 1. So again, make x minus 1 equals to 0. Find the value of x. And then put the value of x in the given expression. And make it equals to 0. So k minus root 2 plus 1 equals to 0, and k equal to, both the terms will go on right side. Their sign gets changed. The value of k equals to root 2 minus 1. And the fourth part is px equals to kx square minus 3x plus k. Px equals to kx square minus 3x plus k. Kx square minus 3x plus k. So make x minus 1 equals to 0. Find the value of x equals to 1. Put the value of x equals to 1 and make it equals to 0. So we get k minus 3 plus k equals to 0. K minus 3 plus k equals to 0, and k plus k, 2k minus 3 equals to 0. 2k equals to 3, and the value of k is 3 by 2. The value of k comes to be 3 by 2.